Hello once again, my dear students. How are you feeling today? I hope you're all good now as we continue with our next lesson. This is still Miss I, your teacher for today, and again, I welcome you all to General Physics 1. Today's lesson is about random error and systematic error. And still it is anchored according to the DEPED's most essential learning competencies for week 1, and that is to differentiate random errors from systematic errors. At the end of this video lesson, you should be able to tell the difference between a random error and a systematic error. So last time, on our previous lessons, we have discussed about measurements and the different type of units and how to convert those units from one to another. And we already have discussed the differences between accuracy and precision. It is very important for us to discuss again or to recall the differences between accuracy and precision, because we will be using this information about accuracy and precision. Again, in accuracy, if the sets of these arrows here or the sets of readings is close to the true value, so this is our true value here. If the readings hit the true value, then we say it's accurate. But if it hits the same, or the same readings, or not exactly the same readings, but at least readings that are close to each other. Okay, so this here, the 4 dots here, so they are near towards each other or near each other, so it's precise. Accurate, again, it's accurate if it hits the target value, and it's precise if the readings are close to each other. So it's precise if it's close to each other even though it did not hit this mark. Okay, so this time we will be discussing the differences between random error and systematic error. So what is a random error? Random errors are error in an indefinite pattern and non-consistent in the experimental data. So for example, 1 minute, your readings might be too small. The next, they might be too large. You cannot predict random error, and these errors are usually unavoidable. While systematic error are errors in a consistent pattern in the experimental data. So because it is consistent, it is easily we can easily identify the error. Okay, so it is a repeatable error associated with faulty equipment or a flawed experiment design. So as I've said, these errors may result to a low accuracy but high precision and may easily be detected. So that's what I have been saying. It may be easily detected, this type of error, because it's consistent. Now let us discuss and identify the difference between random and systematic error. So remember our previous lesson about accuracy and precision. So for example, this here in systematic error, if we see here, we say that the readings are precise because they are close to each other, but it's very far from the true value. This is our true value here, and the readings here are far. So it's not accurate, but it's precise. Now in systematic error, we can easily identify what was the cause of the error. Okay, so we can identify maybe the equipment or the machine is faulty. That's why it keeps on reading the same or similar measurement. That's why it is precise. But in random error, it's very hard or difficult to identify what caused the error, because as you see, the readings here are very far from each other. So what could be the cause of the error? There could be many causes. So it's a random error. This one, we say that it is accurate and precise, as you see here. The readings here is both accurate and precise. If it's both accurate and precise, then we say that your experiment has no error. Oh, diba? Next is, this could be a random error. It's accurate, but it's not precise. So there's a random error, and it's precise, but it's not accurate. So this type of error is a systematic error. Now, the different scale of the random and systematic errors. So we also say, or we also call systematic error as systematic variation, and here we have random variation for random errors. So when do we say that our random error is small, or your systematic error is small, or systematic error is super large? So based from this illustration here, so for example, if your readings, okay, let's change the color. If our readings here is this, oh, it's not clear, let me change. Okay, this one here, as you can see, the reading is not precise, right? It's not precise, but somehow it's accurate because it's near here the yellow, which is the center. So if this is the case, your random error is very large, but your systematic error is small. Okay? If your readings are like this, it's accurate and precise, so your error is just small, random error is small, and your systematic is small. So this is the best measurement, okay, when you have a small error both in random and systematic. Okay, now if it is very precise but not accurate, so we say that your systematic error is super large, but your random error is small. And if it is like this also, so here, oh, this is not the best measurement to see in your experiments because your systematic error is large, and at the same time your random variation or random error is also large. So the best experiment readings here is this one. So this is the best. If you have a small systematic error and you have a small random error. Okay, let's proceed. So what are the causes of these errors and how do we reduce these errors? So for example, the random error is caused by unpredictable variations in the readings of a measurement. For example, incorrectly using the apparatus. So let's say there's no defect, or the apparatus or the equipment is not faulty, there's no defect on that, but the one who's reading it used it incorrectly. So that could be a cause of random error. Another is the parallax error. What's a parallax error? This is how it happens. For example, the reading here is this one here. Okay, that line there, horizontal line. However, if your eyes here is looking above the reading, then you see a different reading or a different measurement. So instead of maybe that is already 70, the exact reading is 70, but you're looking from the top, so because there could be some refraction happening there, and you don't anymore read it exactly. So our reading, for example, if that's a graduated cylinder or a beaker, it must be an eye level. So we really have to look it on the eye level. So if we look it on top, then we see a different reading. So that is an example of parallax error. Okay, so another is, now how can we minimize it? It can be minimized by repeatedly taking the readings. So that means we have to take many readings and then get its average. So that's how we minimize error. Okay, for systematic error, so it is caused by faulty equipment or a flawed experiment design. So for example, from the start, like some of the equipment or some apparatus need to be calibrated first before using. So we have to calibrate first so that we can say that or we can minimize the error. It's very hard for us to get a reading that is really 100% accurate and precise. It's very difficult, but it is important that at least we calibrate the apparatus first so that we can minimize our errors. There could always be errors in our readings, but at least our main goal is to minimize the error. So that's what we do, okay? So for systematic error, again, is caused by faulty equipment or a flawed experiment design. So how can it be eliminated? Using proper technique, calibrating equipment, improve structure of the apparatus.
Thank you so much for watching, class. Are you still confused, or are you able now to differentiate random errors from systematic errors? If you have any questions, please don't hesitate to message me or contact me on my social media accounts as you see flash on the screen. See you on my next video lesson. Until then, bye for now!